Hello everyone, this is Sridhar, Assistant Professor in Mathematics, Marri Institute of Technology and Management. Subject will be DAVC, Differential Equations and Vector Calculus. And the topic will be Ordinary Differential Equations of Higher Order. So in the higher order differential equations, today we are going to discuss type 3 model. Here how to find PI, that is called particular integral for polynomial functions of degree m. Polynomial functions of degree m. So today we are going to discuss how to find a particular integral for x power m or polynomial functions of degree m. First of all, let us see what is the working rule. So here we are going to discuss the working rule to find pi for polynomial functions of degree m. Right? So first of all, we need to take pi equals to 1 by f of d into whatever our given function q of x, that is 1 by f of d into x power m. Right? So in this 1 by f of d, in the denominator f of d, take out the lowest degree term common and rewrite the expression in the form of 1 plus or minus something, that is called pi of d. So here 1 by f of d, in the denominator f of d, take out the lowest degree term common and put in the form of 1 by 1 plus or minus something in terms of d. After rewriting into in terms of 1 plus or minus something in terms of d, now take the denominator into numerator and then expand it. So this one is taken into numerator, then you will get in the form of whole power minus 1. So whole power minus 1, now you can expand it, negative binomial expansion up to n terms. After expanding this, now calculate the derivatives. Before going to calculating the derivatives, first we need to remember one note. So here I am giving the note. What is the note? We already know, suppose d of x cube. For example, what is the derivative of x cube? That we know, 3x square. D square of x cube means 2 times derivative of x cube. That becomes 6x. Again 3 times the derivative of x cube. That becomes 6. 4 times derivative of x cube becomes 0. 5 times the derivative of x cube also becomes 0. So when you are getting zeros, whenever here the x degree will be 3 and the d degree will be 4. Here x degree will be 3 and d degree will be 5. Whenever the derivative is more than the x degree, then the derivative becomes 0. So here we are providing the note that will be d power n of x power m. The value will become 0 for n greater than m. So keep this note and proceed to calculate the derivatives one by one. Right? Now let's discuss one example based on this. Yes, this is a question. So what is the question here? Solve d square y by dx square plus 4y equals to x cube. So what is the right side function here? X cube. Here the x cube is a polynomial function of degree 3. Right. So how to find the solution for this? Generally we know already. The general solution of this type of equations will be y equals to complementary function plus particular integral. Right. So we already know what is the complementary function that we can find for the left side part of the differential equation. That means the solution, complementary function is the solution for the left side part of the differential equation. And similarly, pi is the solution for the right side part of the differential equation. So here we need to find both complementary function as well as particular integral. Okay, let's see how to find a complementary function and then find the particular integral. Okay, let's start finding the complementary function. Right, solution. Let's take the given differential equation. Given differential equation that will be right in the form of a differential operator. So here d square y by dx square I am writing directly d square plus 4 into y that equals to x cube. That means here I am writing this operator form. So here d square plus 4 into y. Here I am writing this f of d into y equals to x cube. Whereas f of d equals to the d square plus 4. Now take the auxiliary equation AE. That is f of m equals to 0. That implies m square plus 4 equals to 0. Now this is a quadratic equation. Find the roots. So I am taking this m square equals to minus 4. Then m equals to plus or minus square root of minus 4. This equals to plus or minus. Now square root of minus means I and square root of 4 means 2. So finally here it becomes a complex root. It becomes a complex root and that will be in the form of alpha plus or minus I beta. Comparing with alpha plus or minus beta, here alpha value becomes 0 and beta becomes 2. So whenever you are getting the roots, the complex number, then what is the complementary function? Then the complementary function, therefore, CF, that is YC equals to e power of alpha x. What is the value of alpha? 0. So e power 0x into C1 cos beta. What is the beta value? 2. So cos 2x plus C2 sin 2x. So it is clearly C1 cos 2x plus C2 sin 2x. That's it. This becomes our required complementary function for the differential equation. Now we need to find particular integral. So what is the right side function here? X cube. That x cube belongs to type 3 model function. That is an algebraic function or polynomial function. Okay, let's start finding the pi. Therefore, pi is 1 by f of d into x cube. Right, we know already here x cube will be a type 3 model function. That means polynomial function. For the polynomial function, what is the working rule? Right. So the first step, take the lowest degree term common from f of d to get an expression of the form 1 plus or minus something. Okay. So here also we need to take the common. This is equals to 1 by f of d. F of d means d square plus 4 into x cube. In the denominator, what is the lowest degree term? Your d square, that is second degree, 4, 0 degree. So from these two, the lowest degree term becomes 4. So 4 take common, 1 by. 4 taking common, then we will get d square by 4 plus 1 into x cube. But in the denominator, we must write in the form of 1 plus or minus something. 1 plus or minus something. So here you can rewrite the denominator. Okay, in the next page, that equals to, right, 1 by 4 into, we can rewrite this 1 plus d square by 4. 1 plus d square by 4 into x cube. So here the denominator we write in the form of 1 plus or minus something in terms of d. Now take the denominator numerator and then expand it. Okay, this is equals to 1 by 4 into denominator is taken to numerator, that is 1 plus d square by 4 whole power minus 1 into x cube. Now this is a negative binomial expansion. So over the negative binomial expansion, that's the formula here I am writing. Okay, 1 by 4 into. So what is the formula for negative binomial expansion? That is, since 1 plus something whole power minus 1. This negative binomial expansion will be 1 minus theta plus theta square minus theta cube plus theta power 4 plus minus theta power 5, keep on continuation. This is a negative binomial expansion formula. So 1 plus something. Here what is something? Compared to theta, d square by 4. So by using this expansion, here I can write there is a d square by 4 plus d square by 4 whole square minus d square by 4 whole cube plus d square by 4 whole power 4, keep on continue to expand into x cube. Next, 1 by 4 into 1 minus, now rewrite all the terms. 1 minus d square by 16 and plus it becomes that d power 4 by 256 and minus continuation into x cube. Here we need to take the terms up to only cube. Why? Because here we need to multiply each and every term. That is 1 by 4 into 1 into x cube minus d square of x cube means 2 times the derivative of x cube. Then I am writing 1 by 16 into 2 times the derivative of x cube. And here 4 times the derivative of x cube. Already we know the derivatives become 0. 5 times, 6 times, all the derivatives become 0. Why? Since d power n of x power m, the value becomes 0 for n greater than m. So that here all the terms will be deleting. Then simplify this. 1 by 4 into x cube minus, what are 2 times the derivative of x cube? 6x. 6x by 16. That's it. This becomes the required particular integral. Right. After finding a particular integral, what is the next step? The last step will be the general solution. Therefore, the general solution of 1 is y equals to CF plus PI. Right, y equals to. Earlier we already found the complementary function. So here CF, right? C1 cos 2x plus C2 sin 2x. That is C1 cos 2x plus C2 sin 2x. Next PI. PI will be this. 1 by 4 into x cube minus 6x by 16. So that you can write x cube by 4 minus, okay, x cancellations. You can write 6x by 64. Any cancellations you can cancel and put the same. This is a required solution. Is the required solution where C1 and C2 are arbitrary constants. Same. In the same way, let's discuss one more example. Right. It is also second order differential equation. And in the right side, we can have x square plus 2x plus 4 is a polynomial function of degree 2. Let's see how to find a solution. Right. As already we know, the general solution for this equation is y equals to cf plus pi. So first of all, find the complementary function and then find the particular integral. As we already know, we can find the complementary function for left side part of the differential equation and pi, particular integral, for right side part of the differential equation. So let's start finding the complementary function first and then find the particular integral. All right, let's start solution. Here the given differential equation is, directly here I am writing the operator form, d square plus d into y equals to x cube plus 2x plus 4. Right. Here the operator form, that is f of d into y equals to x square plus 2x plus 4. Whereas f of d, f of d equals to d square plus d. Now take the auxiliary equation. That auxiliary equation is f of m equals to 0. Then m square plus m equals to 0. Now it will be a quadratic equation, right? We can find the roots, and on solving this equation we get the roots, that m equals to 0 comma minus 1. 0 comma minus 1, both the numbers are real numbers, real, and both are distinct. So in this case, how to write complementary function? That we can write CF, that is yc equals to c1 into e power 0 into x plus c2 into e power 1 into x, minus 1 into x. So finally we get c1 plus c2 into e power of minus x will be the required complementary function. Now we are going to find the particular integral. Now let's start finding the pi, that is 1 by f of d into whatever the right side function that we need to write here, x square plus 2x plus 4. Right. Here we can observe x square plus 2x plus 4, that will be the type 3 model function, means is a polynomial function of degree 2. Right. So what are the working rule for the polynomial functions? Right. First of all, here write the denominator, that is a d square plus d into x square plus 2x plus 4. In denominator, d square plus d, in the denominator take the lowest degree term common. Right. 1 by d writing outside, and then we'll get d plus 1. Now here I am writing directly 1 plus d form into x square plus 2x plus 4. Okay. Now here it will be in the form of 1 plus something. So this 1 plus something we are taking into numerator. The remaining is 1 by d, and here 1 plus d whole power minus 1 into x square plus 2x plus 4. Now this 1 plus d whole power minus 1, that will be a negative binomial expansion formula. So on expansion 1 by d, now let expand this 1 plus d whole power minus 1 expansion is 1 minus d plus d square minus d cube plus d power 4, so on continuation. X square plus 2x plus 4. Here I can minimum, here I need to expand whatever the x highest degree. Here x highest degree will be x square. So at least you need to expand it up to d square term. Okay, right. Continue. Equals to 1 by d into. Here already we know d cube, d power 4, d power 5, d power 6, and all the terms they will becomes eliminated because their degrees will be more than of x degree, so that their derivatives becomes 0. So that we delete it, we eliminated or we deleted. So the remaining will be 1 minus d plus d square into x square plus 2x plus 4. Here why we deleted these terms? The reason is since d power n of x power m, the value becomes 0 for n greater than m. Right. So the next 1 by d into. Now multiply term by term. 1 into this x square plus 2x plus 4. So 1 into x square plus 2x plus 4, that is x square plus 2x plus 4 minus derivative of x square plus 2x plus 4 plus d square, 2 times the derivative of x square plus 2x plus 4. Now calculate the derivatives. 1 by d into x square plus 2x plus 4 minus, what is the derivative of x square? 2x plus the derivative of 2x, 2, and plus the derivative of 4 becomes 0. Leave it. Plus 2 times the derivative of x square, that will be 2, plus 2 times derivative of 2x, 0, plus 0. Simplify this. 1 by d into x square plus 2x plus 4 minus 2x minus 2 plus 2. Minus 2 plus 2 cancel, minus 2x and plus 2x also cancels. The remaining is 1 by d into x square plus 4. Finally, here the remaining will be 1 by d. We already know d means derivative, d by dx. d inverse, that also you can write 1 by d. That means derivative. Sorry, integration. So 1 by d means integration of x square plus 4. So your integration of x square plus 4 into dx. What is integration of x square plus 4? That integration of x square is x cube by 3 plus integration of 4, 4x. That's it. This is our required pi. Next, finally, the general solution. Therefore, the general solution of 1 is y equals to cf and plus pi, complementary function plus particular integral. Okay. What is the complementary function we got earlier? This c1 plus c2 e power minus x. c1 plus c2 e power minus x plus pi, that will be x cube by 3 plus 4x. That's it. Is the required solution. Required solution where c1 and c2 are arbitrary constants. c1 and c2 are arbitrary constants. Okay.